Okay, so it's been a while. I've been running this on my laptop, and then you can see here time elapsed 8,000 seconds, time elapsed 12,000 seconds. This is quite a long time. Uh, that's because this data set's pretty big, and if this had been happening on our server, it wouldn't have taken as long. So anyway, just so you know. So we ran the analysis, and now this last button's come up, Graph and Save Results. I'm going to click it. It asks me, do I want to save the results as MATLAB FIG files, TIFFs, JPGs, or PDF. You can pick whatever you like. I guess I'll pick, if you pick FIG, then later on you can go back and kind of edit the figures if you like. So, and we'll keep them out here in this in the MiCASA V4 folder. Now, one thing to notice is this current results.mat file also now shows up in this folder. That's because this was where we started the data analysis, and these are the results from the data analysis, and we're going to actually plot those results later using this FIGS file. Okay, but for now, this is how the data shows up when we, once we've done the analysis. You'll see a bunch of different figures pop up. This one, I won't talk about them until they're up here. Okay, so this is the total set of figures that are kind of going to come up. Figure 6 is the variance in the coherence, and figure 5 is the coherence itself. For the definitions of these things, please look at the supplementary material and the paper itself. So essentially, the coherence you can see down up to a spatial frequency of about 0.1. So remember, spatial frequency here is going to be 1 over microns, so up to about the 10 micron scale, a little bit smaller. The coherence is right on top of each other, so there's no difference in one set of controls versus the other, which is a good thing. There is a difference in the variance of the coherence. And so, but again, it's fairly noisy, and they're kind of bopping around each other down here. I'm not going to worry about that for right now. Here we have the variance of the red spectra. So this would be the red fluorophore channel. And here again, we see the spectra lie on top of each other, as we'd expect for a control. Here, the variance are a little bit different. These are different data sets. Not too worried about that. And then here is the variance in the green fluorophore spectrum itself. So again, the spectra lie on top of each other. And here, even, well, below about this level, there's a couple of differences in the variance, but roughly these are on top of each other. So those are the results from the analysis. We're all done. We can get rid of our GUI. Okay, so I'm back for a third installment. What I want to do now is to explain a little bit more about how to make some kind of ready for prime time figures from this data. So we just ran the MiCASA GUI, and we're inside this folder called MiCASA-V4. And if we look at the files that we have here, we have this file current results.mat. and that's got the results from that were output by the GUI. And we've included this file wild type MiCASA figs. That file, which is down here in the README file, we could just copy the file name and run it. But I'm not going to do that because I want to show you a little bit of what's inside that file. So here's the file, wild type MiCASA figs. And what it does is it loads the current results. So I'm just going to do this piecemeal so that you can see what's going on. So we have current results here. If I type whos, that shows me all these different variables that were output. And these are the different spectral estimates and the variances of the spectral estimates. And so what the GUI plotted for us looked like this. So this is going to be the plot for the green channel. And there it is. Okay, so I've used slightly different colors here. I've green on gray. I think that looks a little bit nicer. Feel free to use that if you like. But what you can see, and I mentioned this in earlier, that for a control we expect the two estimates to lie right on top of each other, and they do, down quite a ways. These confidence intervals overlap, but down here they don't. But the fact is that this length scale here, so in other words, these are high frequencies, so this is a short separation, a short wavelength. Down here they don't match, but this is not on the length scales that we care to look at. This is on this length scale of the pixel length scale, whereas we're really interested on the cellular length scale and greater. So cellular scales are around 8 microns or so. And so instead of plotting using this axis here, which is a spatial frequency axis, what we're going to do is we're going to use a logarithmic axis down here, and we're going to label the frequencies actually by the size of the period of the wave. So we're also going to label the spatial frequencies with a length scale, and you'll see how that's done. So I'm going to get rid of this one, and this is the same figure but printed with this logarithmic axis for the x-axis. So here it is. And so here, first of all, we've cut off the plot at about 8 microns. And you can see for the entire biologically relevant scale, these confidence intervals nicely overlap. And this is what we would expect for controls. Okay. In other words, the data plotted in green and the data plotted in gray are from the same distribution. And you can see here, so this says this is 8, this is in microns, so this is 8, 16, 32, and so forth. So this is a logarithmic scale. This is still the logarithmic scale. It's actually in decibels for the amplitude of the spectrum. Okay, so, and I'll just show you how the rest of the data looks using this type of plot. Okay, so this is the red fluorophore, and its circularly averaged spectrum. Again, we just plotted over the biologically relevant length scales, and you can see that, of course, it lies on top of each other. And then here, we'll do it for the coherence as well. And the coherences lie on top of each other. So these results are telling us that the spatial structure of the control and of one control and the other control data set are, from the distributional sense, identical, and even the relationships between the red and the green fluorophores are identical, as shown in this coherence. So that's MiCASA analysis, and this last bit has been to show you kind of what we think is a reasonable way to be plotting it. So good luck with the analysis. So one thing is feel free to get in touch with me if you like. There's my email address, and I hope that you have a good experience using this.